We will try to understand the charging of this capacitor through a resistor R. We have a voltage source V, and let's say maybe there is a switch here, and at time t equal to 0 we turn the switch on. The current starts flowing through this resistor and it starts charging this capacitor C, and the positive charge starts accumulating on this capacitor and negative charge here. But because of this resistor, the charging of the capacitor is not instantaneous, because the current is limited through this resistor, and because there is a limited current, it will take a finite amount of time to charge this capacitor. Let's understand this. If we charge this capacitor C through a voltage V, then we know that the charge on this capacitor is given by this formula: Q is equal to CV. I'm giving some real example. Let's say C is 1 farad and this voltage is 10 volt. Then what charge will accumulate on C? The charge accumulated on C will be 10 coulombs. Now, how this 10 coulomb charge can accumulate on it? It will depend upon how much is the current. Let's not talk about this bare wire. There may be some resistor like this here, or something that limits this current in some way. So one way this 10 coulomb charge can accumulate is if we charge it with 1 ampere of current, then this means that this 1 ampere current will have to take 10 seconds to charge it to 10 coulomb. Or if we want to charge it faster, we can increase the current. If we increase this current flowing through this to 10 ampere, it will charge in 1 second. Or if you want even faster, we can charge it with 100 ampere of current. It will take just a split second, 0.1 second, and it will charge to 10 coulomb. The reason I am giving this whole thing is we are coming back to this circuit. This resistor R is going to limit the current flowing through this, maximum current flowing through this circuit. If we increase the value of R, the current will reduce and it will take more time to charge this capacitor. But the story is not that simple. The reason is this. For example, we could say that, okay, let's say we have a 10 volt battery and we have a R equal to 1 ohm resistor. Then we could say, okay, the current flowing through this resistor could be 10 ampere and then it will charge in 1 second. But here is the problem. The problem is its dependence with the time. What happens is, if without the resistor it would have charged instantaneously, even though it would require a very huge rush of current. When we put a resistor R initially at time t equal to 0, for a very small point of at the very beginning, this current I is given by V divided by R. Now what happens is, as the current starts flowing, the capacitor starts getting charged, and because of the charge accumulated on this resistor, this starts acting like a battery, which will reduce the voltage across this resistor. You can think of it, let's say at some point of time, the voltage accumulated on this charge is 1/4 volt. Then what will happen? The resistance available across this resistor, the voltage available across this resistor will be V minus 1/4 of V. And in that case, the current through this resistor is going to be V minus 1/4 of V divided by R, or 3/4 of RV. Now let's say some more time passes and the voltage across this capacitor increases to half of this volt. In that case, the current across this resistor will become I is equal to V minus half V divided by R, or half of VR. And if we voltage further increases to 3/4 of across this capacitor increases to 3/4 of R, then this I will become 1/4 of an R. So here is this plot. This is how it looks. The plot looks like the variation of this current with time. Initially, this current is V by R. At some point of time, the voltage charges and the current flowing through it becomes 3/4, then half of V volt, then 1/4, and slowly, and finally, after a long period of time, the current tends to 0. So we know that there is a dependence of I with T, and this is a very transient state. This is called transient state because it happens usually for a very small period of time initially, and the current settles down to 0 volt because current cannot flow through. We know that the current cannot flow through this capacitor C. Now what we have to do is we need to derive a formula for the dependence of this current I with respect to time, and then we also will like to know what is the dependence of the voltage across this capacitor V, voltage across the capacitor C with respect to time, because voltage on this capacitor does not instantaneously reaches to V. Because of this resistor, it takes some time to reach this. We need to derive the formula for this, and to derive this formula we will need differentiation and solving the differential equation. If you do not know this, go through and take some differential equation, some very basic differential equation chapter, or refresh yourself, and then you will come to another video that will derive the equations of the charging of a capacitor. Then we also will take a look at the discharging of a capacitor and several other circuits in the video.